So this app is called RV Motion, and it's a motion analyzer. That means that mostly the role that it takes is you take a video from your camera roll and you're able to plot points of something that you want to measure when it's moving, and then it's going to give you graphs and stuff like that that represent this, which we'll show it on later in the app. One of the big downfalls of this app, however, is that it's not that easy to use because there's no instructions. I couldn't find any tutorials within the app. I read about it and it just wasn't very clear what I was supposed to do, so the only way I could really get to start using it is by actually working with it and using it. So here I'm scaling the units as whatever I want them to be, which is one of the different 4 settings there are. So which is cool because the measurements can then be accurate to real life data. And then it's compatible for basically any situation that you want to choose, be it something really far away or something close, like in the example here. So what it's going to see is I can choose a point to start at, and then I can connect that to different points and stuff like that. So this is my first trial that I did, just trying to see how it works, trying to move around the axes from a video that I had from a few months ago. It definitely helps conceptualize position and speed through the analysis of motion, I would say, because it relies a lot on position, which is something I often think we don't think about as much, and it makes it a lot easier to think about real life situations and where velocity is coming from and stuff like that once we actually get into the graphs, which, as we know, are the derivatives. So you can set up and define your axes of motion, which is happening here. And so then you can put that with, if you notice the plus 90 degrees, if I were to do that, which I believe I do later on in the video, you can change the axes, and you can also rotate the axes so that it can fit any sort of like free body diagram style you would be doing, or just any situation like if it's a mass on a tilt. So here's a different video. And that's just of me throwing a projectile. It's another attempt. It's not a very good one because I was just trying to figure out like what the different mechanisms of the app did. So you can calculate and map the trajectory of a video from your camera roll. Here is the one I was trying to do, though I have one later on that actually is much more effective. So it's going to measure the different bits of movement, and here it's only going to end up showing the X displacement, as we'll see in a minute. But here I'm estimating where I think it's going to hit based on where I'm throwing the gum wrapper, and then I'm seeing if I'm able to map it, but clearly I am struggling because it's not really doing what I think it would, and I'm keeping my axes at their normal or regular stance. So one of the most important and useful features to point out on this app is that little circle that zooms in so you can choose a really accurate point. If you didn't have that, it wouldn't be as clear. You're not able to be as focused on what you might want to show. And it's also what you definitely need to use for marking points in the trajectory. So what I'm also doing here is moving my axes around, figuring out what the best spot for them to be is, and if you notice at the bottom there's a way you can measure throughout the app how long the time is, and you can make it go really, really slowly so that you get the exact moment that you want, which I think is really important because it's difficult to pause on the exact moment that you want when you're doing a problem like this. So I'm moving around the axes, plotting different types of points, stuff like that. So now I'm transferring to if I had a second type of data that I wanted to compare to it. You have red or blue that can then be compared later on. But I'm only using red for a minute because I was only measuring one thing. So on the graphs, it won't show up as something as useful as the blue values that I had been measuring before. But you see how there's 2 separate dots that now you can see because you're doing 2 separate data sets. So here's the graphs that you can see. This is the one for X displacement, then X velocity, then Y displacement, then Y velocity. So obviously there isn't any Y velocity because you're not really able to tell what's going on. But it's pretty great that the graph is so accessible to you because it makes it a lot easier to actually get the video to be transcribed into the data that you would actually want to use. Okay, so this is the next video that I did. So what I did here is I throw a teddy bear into the air, and I'm going to map its projectile motion and then its x displacement and all of that using this app. So first what I have to do is I have to cut down the video, which is actually a lot more difficult than it would seem. It doesn't really work that well with what I was trying to do, and it's generally pretty difficult to use, and actually at the top it doesn't even let you bring the beginning any shorter, which I particularly found pretty frustrating. So here is where I move on to actually being able to map motion and then the graphs being much more accurate. So what I'm going to do here is I have to find the particular part of the video that I want, and then I can use the zoom aspect to start to choose points. The possible error that I had here was not picking points that are on the same part of the teddy bear. For example, one might be the stomach, one might be the leg for different parts of the video. So I'm going to acknowledge that to begin with. So here I can start to do it, and each time I click it, it'll naturally move forward, which I thought was really helpful, so that there's a constant amount of time that it's moving forward for each data point, which can then be seen on the graph. So this takes a minute, and my axes are defined, as you can see, as y up, x positive, as it normally would be because it's a real life situation and there's no tilt or anything like that. It's just me standing up on my floor. What's really helpful in this is that because we can set up and define the axes that the motion is going along, the paths can be seen in the negative and positive x displacement in relation to the axes, which is going to make it really interesting for when we look at the graphs later, because we're actually able to see the parabolic movement of it and how the derivative is based on that, with it going negative and going positive and zeroing out. Here you can see each of the data points that I chose using the zoom circle along the teddy bear's projectile motion, and then I can check through back the video, and then it'll show you its motion along with it plotting the points as the video goes on, so you can make sure that it's actually lining up how you would want it to, which I think is also really good. Once again, I'm just looking at the 1 and 2, though I still only need 1. So now I can look at the graphs. X displacement, which as you can see is just going up. It's like just displacing a pretty even amount along the x-axis. The x velocity is interesting because of the speeds, and that's most to do with the error from the points. The y displacement shows pretty parabolic, like I was talking about, which makes a lot of sense for this type of movement, and so I'm glad that that worked out, other than the top where there's obviously some type of thing, but it would line up with regression. And then the y velocity shows where it's zeroing out and tells us a lot about how the motion's moving in comparison to those axes that I defined. But if I were to define different axes, obviously it would be something different. Also, something to point out is that the graphs give you the time as well, which makes it really, really easy to put back into calculations that you would want to do. Once again, I can put in any units that I would want. I estimated that it would be about 1 foot for where it would be, but I'm not exactly sure how accurate that was because I didn't measure it myself, but it's good to know that it can be used for any type of distance, so that if you're, for example, doing a basketball, you can have it be further away, but if you're doing something really close up, then it would be much easier to use than if it didn't have that. And this is me rotating the axes. I can do the plus 90 also, so that it shows me the first data. It'll go to the beginning and then the last data to show how the axes are defined at each point, which I think is really helpful as well. And so then you can see that the axes are dependent on the points, not just on where you place them. And so each data point can be considered an origin if you move the axes to that area. So the pros that I want to acknowledge is that it works really, really well. The graphs are pretty nice. It's pretty easy to use. But setting it up and doing trials can be difficult, and it doesn't acknowledge that much uncertainty. Okay, thank you so much for watching. I hope this can be helpful next time you have a project or anything like that.